right, so your tasks are to define inertia, how does inertia affect motion, what's the relationship between inertia and mass, and then explain how to overcome inertia. So at the beginning of every Bill Nye video, they always say inertia is a property of matter. Okay, so just like attraction and repulsion being a product of matter or a characteristic of matter, so is inertia. It's a property. Okay. So at Newton's skate park, Lauren is pushing her twin cousins, Jonathan and Cody, on her skateboard. She has to push hard to get the skateboard started, but once it begins moving, it takes much less effort to keep it rolling on a smooth, flat pavement. In fact, if Lauren tries to stop the rolling skateboard, it may take as much effort to stop it as it did to get it rolling in the first place. So why is it harder? Well, the answer is inertia. Once you get an object going, it wants to continue to do that. That's its property. That's what it does. So inertia is the tendency of an object to resist a change in motion. All objects have inertia, whether they are stationary or moving, so whether they're still or if they're in motion. Inertia explains Newton's first law of motion, which says that an object at rest will remain at rest. An object in motion will stay in motion unless acted on by an unbalanced force. Wow. It's a lot of words. Big, big words. That's why Newton's first law of motion is sometimes called the law of inertia. Okay. Came up with these ideas during the bubonic plague. So I wonder what we're going to come up with in the middle of this pandemic. Yeah. You probably don't realize it, but you experience inertia all the time, and you don't have to ride a skateboard. For example, think about what happens when you're riding in a car and the car has to suddenly stop. What happens to you?
You kind of like do the thing.
You kind of do the thing, yeah, that nonverbal moving forward. Because however fast the car is going, you are too. So if the car is going 25 miles per hour, so are you. And so your body has to react after the unbalanced force, the brakes, are applied. So if the brakes are applied suddenly, your body is still going to move in a straight line. What catches you?
The belt.
Seatbelt catches you. Okay? That is their whole purpose. That's their job. Okay? And in the video that I put up for you to watch on Monday, it talks about the importance of being tethered to your vehicle. Okay? I had a student years ago was ejected from a car. He was actually in the back seat. Didn't have a seatbelt on. He was ejected and killed. So wearing that seatbelt is very important because it keeps you tethered to that vehicle. If you're tethered to the vehicle, chances of being hurt are cut way down. So brakes will stop the car, but your body doesn't stop moving at the same rate. Because if your car is going 25 miles per hour and you suddenly stop, well, your body's also going 25 miles per hour, so it takes a little bit for your body to stop. So it goes forward. So that seatbelt grabs you and pulls you back. One of the things that they've also developed with seatbelts is, have you ever noticed if somebody has their foot on the brake, how you can't really move?
Yeah.
Yeah, same thing. Okay. They're designed that way. So as long as somebody has their foot on the brake, you're kind of like, hey, I need to turn around to, no, not till they let up off the brake. So what's the communication, or what's the deal with inertia and mass? Well, the inertia of an object will depend on its mass. The greater the mass that something has, the greater its ability to resist change. Mass and weight are related, but they're not exactly the same. Mass has to do with the amount of stuff in an object, where weight is a measurement of gravity and how gravity pulls on you. Your gravity will be different. If you go to the moon, you will weigh 1/6 of what you weigh on Earth.
I'm moving to the moon. Who's coming?
If you move to Jupiter, you're going to double your weight.
Never mind. I'm good.
So your mass will always be the same because you're still made up of the same stuff. So objects with greater mass also have greater inertia. It would be easier for Lauren to push just one of her cousins on the skateboard than both of them. With just one twin, there would be only half as much mass on the skateboard, so there would be less inertia to overcome. I want to show you this video because it's kind of cool. Notice how the balloon keeps its shape for a moment.
Hey everyone,
Welcome to another episode of Science in Slow Motion.
in this episode we're going to look at the inertia of water inside a water balloon.
And Mr. Dursley is going to get wet.
That was cold. Why would you do that to me?
Sometimes you have to make sacrifices for science.
Okay, fine. So what exactly is inertia?
Newton's first law of motion, also known as the law of inertia, states that an object in motion will remain in motion unless an outside net force acts on it. But an object at rest will remain at rest unless a net force acts on it, changes its motion.
Cool language, friend. The word inertia comes from a Latin word that means lazy or idle. So does that mean matter is lazy and it resists changing its motion?
I guess you could say that.
So how does popping a water balloon demonstrate inertia?
Right now, the balloon is holding in the water with its elastic force. The force of gravity is trying to pull the balloon down, and my hand is pulling the balloon up.
So right now the forces are all balanced.
When I pop the balloon, the elastic force of the balloon pulls itself away, but the inertia of the water, because of its mass, makes it resist moving. So it seems to stay still for a moment before the force of gravity starts making it accelerate downward.
But the green material of the balloon itself has way less mass and therefore less inertia to hold it in place. So it flips itself away from the balloon quickly.
And because the water has so much more mass and inertia than the balloon material, the balloon doesn't disturb the main mass of water. Basically, it does the easiest thing it can, which is to go around the water rather than move the water.
So it's lazy.
Right.
And look at that. Even as it starts falling, the water holds its shape right up until it hits my head because its inertia makes it resist any change.
Notice the spray around the water? All the little droplets you see are being pulled away from the main part of the balloon because they adhered to the balloon.
Wait, water sticks to the balloon? Are you saying water is sticky?
That's right. We don't usually think of water as being sticky, but it does adhere to things.
Okay, there's one more weird thing I'm seeing in the video here. What is that octopus arm thing coming off the rest of the balloon?
That's interesting. What's happening there is that when I pop the balloon with a pin, there's a tiny fraction of a second in which there's a small circular hole before the rest of the balloon tears itself in half. In that tiny split second, the balloon's elastic force pushes water out the small hole, creating the shape you see. Then, as the rest of the balloon flies away, the inertia of that area of water makes it continue to move outward away from the main mass of water. So as the water globe falls, that little arm keeps extending itself. In fact, if your head hadn't been in the way, that arm probably probably would have kept getting bigger.
That's kind of awesome.
That's Newton's first law of motion.
All right. So overcoming inertia, to change the motion of an object, inertia must be overcome by an unbalanced force acting on the object. The unbalanced force that starts Lauren's cousin's rolling along on the skateboard is applied by Lauren when she gives it a push. Once an object starts moving, inertia keeps it moving without any additional force being applied. In fact, it won't stop moving unless another unbalanced force opposes its motion. For example, Lauren can stop the rolling skateboard by moving to the other end and pushing the opposite direction. But what if Lauren didn't stop the skateboard this way? If it remained on a flat, smooth surface, would it just keep rolling forever? Short answer is usually yes, but the inertia of a moving skateboard will keep rolling forever if no other unbalanced force opposes it. However, we do have that thing called friction. Can't get away with it. Just, it's always there. It's the only way you can get around it is to go to space or slide things on ice or air. So what other force is it? We call it rolling friction between the skateboard wheels and the ground. There's lots of different types of friction, but in this case, yeah. All right. So later that day, Jonathan rode his skateboard and did some jumps. He's in a photo right here. He's in the air, so there's no rolling friction between his wheels and the ground, but there is still another unbalanced force acting on it, which would be what? Gravity. So gravity is always acting on us, okay? It will pull the skateboard back down toward the ground. Once it is on the ground, then the friction will slow its motion to a stop. What questions do you have? Yes. You're not answering those questions.